Okay, problem number 10. This is a calculator problem, and I actually tried doing it without a calculator, and then I came to the bottom, and it said, hence, write down the area of R. I'm like, hence? I'd have to do a ton of work. So therefore, I must have to use the calculator, because they must want me to just put my expression into the calculator to get the area. All right, so back to the top, and we are going to use the calculator. So first of all, write down, this is the first derivative of the function. Notice this different notation. This just means f of x equals. Okay, so when in doubt, just guess. You got to figure that out. That must mean f of x equals. It's just another way of writing it. So my first derivative is going to be 2 times negative 1/2. That would be negative 1. So negative x squared plus 2. So there's my first derivative. Oops, sorry, negative x. Why did I leave the square? Negative x plus 2. Okay, now they say evaluate that when x equals 0, so negative 0 plus 2 is equal to 2. Now let n be the normal to the curve at the point where the graph intersects the y-axis. So if I actually graph this, because now that I've determined this is a graphing problem, if I graph this, let's see what it looks like, negative 0.5 x squared plus 2x plus 2.5, clear that. Graph it. So there it is. I'm going to go ahead and change my window. Let's see, I want zoom 6. See what that looks like. Okay, so there's my parabola. So let n be the normal to the curve at the point where the graph intersects the y-axis. Okay, so if I think about this, I've got this parabola, and where it's crossing the y-axis right there, the y-intercept would be at 2.5. Okay, this is going to be at 2.5 because when x is 0, so negative 0.5 times 0 squared plus 2 times 0 plus 2.5. What does the y equal there? It equals 2.5. So this point right here is going to be at 0, 2.5. That's my y-intercept. And is normal to the curve at the point where the graph intersects the y-axis. So here's the tangent, the normal is perpendicular. So this is going to be my normal is going to be like that. All right, I can find the slope of the normal by first finding the slope of the tangent. Well, when x is 0, I actually already found that. This is the slope of the tangent because the derivative tells us the slope at any given point on the parabola. I want to know what is the slope when x is 0. Okay, that's this point right here. When x is 0, the slope is 2. So I know for my tangent, the slope is 2. Therefore, for my normal, the slope is going to be the perpendicular reciprocal. Sorry, it's going to be the opposite reciprocal of that, which is negative 1/2. So m is going to be equal to negative 1/2. Because this is the slope of the tangent. This is the slope of the tangent at the y-intercept, slope of the tangent at the y-intercept. So this is the opposite reciprocal. So that's going to be the slope of the normal. And then I'm going to have y equals mx plus b. I know the slope is negative 1/2. And I have a point. I have the point 0, 2.5. That is on the normal.
Good afternoon. There's a Teachers Association meeting at D6 right now. Teachers Association meeting at D6 right now.
Holy cow, that scared me to death. Okay. Anyway, let's keep going. So I substituted in my y-intercept. 0 times negative 1/2 is 0. B is equal to 2.5. Oh, duh. I already had the y-intercept. B is the y-intercept. Okay, that was extraneous. I didn't need to do that. All right, so y is equal to negative 1/2 x plus 2.5, which is the same as negative 0.5 x plus 2.5. Those are the same things. All right, draw a sketch of f of x and g of x. Actually, I kind of did that up there, but let's go ahead and do it on here. I'm going to enter in that other equation, so negative 0.5x plus 2.5. And let's graph both of them. Oh, that's interesting. Look where they cross each other. Okay, so if I sketch this on, I have 2.5 about here. -1 is where it's crossing, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is where it's crossing, and it looks like it's going like this. There's my parabola, and here is my g of x. Okay, so this is g of x, and this is f of x. All right, and I know they cross there, and it looks like they cross over here as well. Find the solutions for f of x equals g of x. Okay, that means the intersections. So I already have this one, and the other one I would get by doing -0.5x plus 2.5 is equal to the parabola, which is -0.5x squared plus 2x plus 2.5. Set those equal to each other, and since I already have it here on my calculator, by the graphing display calculator, I'm going to use my intersection, and let's just check. It looks like it's at 5 and 0, but let's double check. Enter, 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 and I get 5, 0. Yeah, so the other one is at 5, 0, and I got that by using my graphic display calculator, so 5 and 0. Hence, find the coordinates of the other point of intersection of the normal and the curve. Oh, so sorry, find the solutions. The solutions would be x equals 0 and 5. Those would be the answers there. Find the coordinates. That would be 0, 2.5 and 0, 5. Let R be the region enclosed between the curve and n. Okay, g of x must be n. Is that what I'm hearing? What is n? Oh, that's the normal. Okay, n is the normal, which is g of x. Okay, that's the same thing. G of x is the normal. So enclosed between the curve and the normal. So I am looking for this area. Okay, enclosed between the curve and n. That is the region enclosed between the curve and n. So to do the area between two curves, I'm going to integrate between 0 and 5, because that's where the intersections are. And I'm going to do the top curve minus the bottom curve. So the top curve is -0.5x squared plus 2x plus 2.5 minus the bottom curve, which is -0.5x plus 2.5, the whole thing, dx. So there's an expression, and then it says, hence, write down the area of R. So in other words, I can just enter this into my calculator. So let's see if I can just do it like that. So I'm going to, I already have the first one in here, so let's insert some parentheses. Not that that's really needed. Minus, then the second one, -0.5x plus 2.5. Okay, I got them both in there. Let's get rid of that other equation. And then I'm going to integrate that. And I'm going to do it from 0 to 7, as soon as it's ready. 0 to 5, sorry. Why did I say 7? 0, enter. 5, enter. And it gives me 10. The area is equal to 10.42, or actually 3 significant figures would just be 10.4, because that 0 is significant because it's between two non-zero numbers. And that would be, we're talking about area, so that would be units squared. There is number 10.